All right. So welcome everyone to today's very exciting webinar. So this is the first of a series on astrophotography that is being organized by the LIGO-India public outreach team. So my name is Debarati Chatterjee. I am chairperson of education and public outreach for LIGO-India. And this is going to be a very exciting series where you get to learn the basics of astrophotography and also to be able to interact with the experts, ask them questions, and even participate in a contest at the end of this series. So let me welcome Rakesh Rao, who is the first speaker of this series. It's my great pleasure to have you as a guest speaker. So Rakesh is a well-known photographer and filmmaker and a science enthusiast who specializes in documenting science expeditions and research activities. So he's been involved in many projects that has taken him as far as the Arctic, Antarctic, and the Himalayas. And he's among the few filmmakers who has done that. So his recent film, Climate Challenge, won the Best Science Film Award at the International Science Film Festival of India, and the film also received the Golden Beaver Award at the 10th National Science Film Festival. So he's been part of more than 10 scientific expeditions and even worked on developing films for very many important research projects like Chandrayaan-2 for ISRO and Koena Deep Drilling Project. So without much ado, let me welcome Rakesh. So please take it away.
Thank you, Debarati, for having me here and organizing this wonderful series of webinars. And during our interaction, I got to know that you're inviting a couple of renowned astrophotographers. I mean, some of them have been. I look up to them for some of their amazing work that they do. I'm sure everybody, and in fact, today I'm going to share my experience, but I'll be for sure joining as a participant to listen to some of the other mentors who are there who will be speaking around. So let me share my screen and we can get it started. Yeah, is my screen visible?
Yes, it is.
Okay. So before I start, let me just tell an update to the participants here. If you'll have any questions, probably you can, we can keep it to the end. We have 15 minutes kept for the Q&A. Or if you all feel that you all might forget down the line or something like that, you can just raise your hand or you can just put it up in the chat box and we can take it up at the end or things of that sort. So good evening. I don't know, should I say today being, once we got into this COVID realm, I don't know what to say, whether should I say to people, good morning, good afternoon, good evening, or good night, because nowadays, the world has become so small post-COVID that we all connect from all across the places. But from wherever you all are, I hope you all are having a good time and a good evening. For me, it's evening, so I wish you all good evening. And I hope it's not raining up there, because here in Goa, we just underwent a very bad thunderstorm and heavy rains. So just in case you see the lights go off or internet go off, just hold on. I'll just reconnect and fix up that particular thing. Because I don't know what is the connection between rains and electricity. They keep shutting it on and off whenever they hear a thunderstorm kind of a thing. So yeah. Although you've got an introduction about me, but I'll just do a small different introduction about myself and what I do. So what basically I do is I try and communicate science. And in the process of communicating science, I use the medium of photographs and films to do so. Oh, okay, sorry. I just have an instruction to, okay. So in the process of doing it, I end up, one second, yeah. I end up, I use the medium of photographs and films to communicate science. So, and over the last almost 12 to 14 years now, I've had this amazing privilege to work with some of the most renowned and prestigious research institutions in India, and been part of some of the most amazing projects that they have undertaken, and I've got a chance to actually go ahead and document all of that. I know this is wrong for me to say this, but then I do consider myself to be having the world's coolest job. It's not that your jobs are not cool. Mine is a bit cooler because I say this because my previous 3 expeditions have actually been to some of the world's coolest places of Arctic, Antarctic, and the Himalayas. And of course, I did end up, sailing for almost 2 months in one of the roughest possible ocean called the Southern Ocean, and documenting researchers basically, and all the research that they're doing, whether it's geology, microbiology, environmental sciences, climate change, astronomy also, and coming up with series of films. So I've been part of several scientific expeditions. So that's why I consider to be having the world's coolest as in the coldest job that's there. And in that process, I've ended up recently developing a film called The Climate Challenge. The film is available on YouTube. It's in public domain, so feel free to watch it, share it, pirate it, if I have to say that. It's the idea is to just share and tell people about what the problems are happening in some of these places. But at the same time, if you notice, the film is not about it's not called the climate change. It's called the climate challenge, because the film does talk about how our researchers go to these extreme places and actually face sometimes, life-threatening situations to actually go and get the climate data. I mean, we in India, we have this stereotypical notion that when I say the word scientist, and this is what we end up doing whenever we go to any schools and colleges for any talks. And when I say the word scientist, everybody has a very stereotypical answer that they wear glasses, they wear lab coats and mix chemicals and things like that, which is partly true. But there are also these scientists who go to, survive -30, -40, and go to 18,000, 19,000 feet, which is like almost 60% of about 60% of the Earth's atmosphere, just to get their climate data, and sometimes even facing life-threatening situations. So if you're free and want to tomorrow, I mean over the weekend, if you all want to spend some time trying to understand something, the film is available on YouTube. You can just type climate challenge, or you can go to the website and have a look at it. One of the key projects that we did, we called it the Astro Project. And the project actually, we were very happy that there was an open call for proposals from all across the world from the IAU's Office for Astronomy for Development. And so they received some 400 odd projects. And out of which they selected 7 projects for doing outreach. And we were very proud to have one of our projects selected. And the project actually, the idea of the project was to document astronomy research happening in India, and also document a couple of, in fact, most of them, in fact, all observatories in India, spanning all the way from Kodaikanal all the way to the Henley Observatory at Ladakh. So we have developed a series of films. We are still developing many more. But last couple of years, I've just kind of shifted to the work on climate change and a couple of expeditions. So we had to take down the website for some reason, but early next year, the website should be up, and a lot of other information is coming. And I look forward for you all also participating and helping us, propagate the stuff and tell people about what research is happening, and also inform people about the kind of observatories. I'll be telling a couple of stories about these observatories in the presentation. So yeah, hang along. These are some of the observatories that we documented. The top is the Himalayan Chandra Telescope, IAO, that is the Indian Astronomical Observatory at Ladakh, that is almost at 15,000 feet. The one on the right where you see the cursor moving is the Venubapu Observatory. The one below is the Ayuka Giravali Observatory in Maharashtra, Kodaikanal Solar Observatory, Mount Abu, and this is the Udaipur Lake Observatory, Solar Observatory. Then in Nainital, we have one. And we also have one second, just a second, sorry. We also have the GMRT and the UT radio telescope. So there are a couple of observatories, and they have so much amount of work that's happening out there. And sadly, people didn't know much. So they all the outreach has now started in full swing in India, and people are getting to know. And I really appreciate LIGO-India taking this forward and organizing these webinar series and the connect between the locals and the people and the scientific community. So as a part of that project, we also did one film, a main film called From Dust to Stars, which talks about the formation of how the stars are formed and things of that sort. So the film is again available on YouTube. You can just type Astro Project, or you can just type From Dust to Stars, and I think you should be able to see it. Or you can connect with me and I can share you the link. So coming to today's topic of capturing or photographing the night sky. But before I just delve into it, let me talk a bit about history. I won't bore you all more about the history side of it, but it's very important if we want to understand the context of capturing stuff. It's only when you delve and understand the rich history, you will enjoy the field of getting into astrophotography and things of that sort. You'll start enjoying when you click your stuff. Yeah, so people, the humans, when they evolved, the best part about astronomy is that astronomy is considered as the youngest science, because we're constantly evolving. We're constantly, trying to see things and develop stuff and understand on a constant process, with new technologies coming in, and maybe probably down the line, several centuries down the line, we are thinking of migrating to different planets and the new telescopes which are going up and things. So we're constantly understanding. So it's very new for that matter, this particular field. But the best part about astronomy, it is also considered as one of the oldest possible sciences. The reason I say this is because when humans evolved and started understanding stuff and started noticing patterns up in the sky, they started documenting it. Sadly, during those days, they never had the technology that we have today, but they used all possible forms and means to document what was happening up in the sky in form of rock art of petroglyphs, or embedding in form of a bronze structure kind of a thing, or noting it down as much as possible in the kind of old paper formats and things of that sort. But as technology evolved, and even much before that, when people there were no nothing else to do at night, like how, although we have so much of things, maybe it's Netflix or any Saas Bahu serials that we end up watching, or any of the the films or something. Sadly, the historic people, they never had any of this sort of entertainment. So when the night sets in, all they could do is just have their dinner and watch the skies. And when they started watching the skies, they started noticing all these amazing patterns, and they started connecting the dots, the stars, basically. And they started noticing all these heavenly living and non-living creatures up in the sky, right from bear to people to snakes to ship to all possible hunters and things of that sort. So there was a constant effort to actually document the night sky. And it was sad that they did not have the technology. Probably, I think they would be watching some of the best skies that they could have, because there was no electricity, there was no light pollution that we deal today with, and probably the skies were much better without this pollution and aerosols high up in the sky. I just try to wonder, I mean, what is the kind of skies that they would be actually having, seeing up during those days, kind of thing. So as things evolved, probably I'm just hopping in a much major leap, and just trying to see the milestones in some of them. So when Galileo probably used the telescope for the right thing, Galileo never invented the telescope. It was Hans Lippershey, but he actually, instead of peeping in and seeing in on the land, he pointed it towards the sky. And when he saw it, the new universe actually opened up. He started seeing stuff which were barely visible through naked eye. And the only way he could document all of that was through sketching. He started drawing all these features. So these were the early attempts to try and understand the night sky and capture them in the form of all possible forms, except for photography, because photography had not evolved, and it did not evolve all the way up till the early 18th century, when this particular gentleman, a French person, Nicephore Niepce, there was this so-called technology at that time called the Camera Obscura. That was a technology of that time, but now today we use it. Kids develop it in the form of a pinhole camera. So what they used to do is have a small dark room. Camera Obscura actually translate to a thing called as a dark room, and all they do is just have a small hole, and have with proportionate size of the hole and the distance, they could actually have the outside image actually projected on the dark room, inside the dark room, but inverted. And then they used to sit there and sketch the entire outside scene. So that used to be a tedious process of doing it, kind of thing. So it was only up till when Nicephore Niepce, decided that instead of doing all these stuff of drawing and etching and sketching, why not try and capture the light? So he came up with this thing of having a metal plate coated with silver chloride, I believe, and tried and exposed it into the Camera Obscura to capture, which is apparently called the first photographic image that has been preserved from the time when it's all started. So he's been given the credit to actually start photography. But just understand the painful taking process. This entire thing, there are multiple accounts to this. Some people say that it has taken him 8 hours to click this photograph. Some people say it has taken him almost close to 20 days to click this photograph, because he died in 1833, and there was no account of how he actually captured this particular image. Because they say 8 hours, because if you see both the sides of the wall, this is actually a image of his from his window. It's a building that he saw. If you see on the left and the right side of the wall, both of them have been equally lit. So people, researchers thought that it's because the sun that has moved from east to west and has lit the particular place. So it has taken more than 8 hours to do it. And it was a tedious and time-consuming process to take one image, because he had to and he had a lot of unsuccessful evolution in that sense, because that the silver chloride, what he had on his metal plate, did not give him proper positives. He never understood that it is negatives that he was capturing, and things of that sort. But soon we had this gentleman, so John Herschel, which I'm sure everybody knows him as his father was the discoverer. So William Herschel was the discoverer of the planet Uranus. And he himself was an astronomer who also has given names to a couple of moons of Uranus. But he was the one who actually developed another kind of technology called cyanoprints, which were used till today. A couple of years back, though, the blueprints that you all do for any architectural drawings and things of that sort, because he's idea of he was the one who invented it. You can just Google up something called a cyanoprints if you all want to know more about it. So, but he's actually the one who is credited to introducing the term photography, which is a Greek word which actually means photo is the lights or the photons, and graphos is drawing with light. So photography got coined by John Herschel. And slowly, as things evolved, people started getting interested in this form of art, and the technology evolved. There was this person, Louis Daguerre, and he developed this particular camera, and he used a different emulsion technique instead of silver chloride, which used to take long time for exposure and getting sensitized. He used some different technology like silver iodide, and then used some fumes of mercury and few other stuff to actually generate a faster processing technique. And he made these cameras called daguerreotype, which were very much in use till early 19th century. I don't know if some of them have seen it. Even if you have gone to some old museums or something, you'll find these box structures where the photographer used to actually hide behind a curtain and take a snapshot on a glass plate and then go and develop it, kind of a thing. So he developed this particular camera called the daguerreotype. And this is probably, what you're watching is probably the first human photo. If you see the photo, what you realize is that there's just two human beings here. One of them was getting his shoes polished, while the rest of the scene looks deserted. The reason being that it is actually not deserted. It's just that there's this road and there were a lot of traffic also on the road. But when you give a longer exposure, many of the moving objects tend to disappear. The only static object that was there was this person who was getting his shoes polished. So he stood there for almost 8 minutes, 8 to 10 minutes, getting his shoes polished. So he got captured while the rest of all the motion got negated and just disappeared from the photograph. So this actually became the first human photo. And again, from 8 hours to 20 days of exposure, it came down to just 8 minutes and lesser than that. And soon it was John William Draper, one of the scientists, American scientists. He too, instead of using camera just to capture things on the Earth, he moves the camera towards the sky. And this is known to be the first, and this is considered as the start of astrophotography. I mean, this is where he actually captured the first surviving image of the moon, which was very much in detail, but during preservation time, almost 200 years old. A lot of fungus grew over it, and that is what you end up seeing with all these structures. But this is the moon, one of the phases of moon that he captured. And probably this is the first astrophotograph that got attributed, and the entire scenario of using camera to capture celestials started from here. Soon daguerreotypes became the new norm, and many cameras started getting formed, and invention started. So much more easier, smaller, and better processing techniques started. And so this is a photograph taken by Berkovsky, a Russian, initially in the Soviet Union, but now in Russia. He captured the first total solar eclipse image using a daguerreotype process. So as you saw, slowly the astrophotography started taking a niche, and soon this is considered as the first image of the Orion Nebula. So it was astronomer Henry Draper who actually attached this daguerreotype to a telescope and tried to get a detailed image of the Orion Nebula. Although the telescope did have a manual tracking mode with gravity and weights and things of that sort, which generally tracked at that time. But at the same time, if you notice, the image is not sharp because to get such an image, you have to give longer exposure. Now, he actually gave almost 51 minutes of exposure. So tracking 51 minutes of Orion Nebula during those days were difficult, and hence the imaging, what could come out was not that sharp. But things changed from there. It went to photographic plates, and photographic plates became the new norm of photography. And soon after photographic plates came the film roll that I'm sure, I don't know how many of you all have used it, but I started my career of photography using film rolls kind of thing. But these photographic plates were the new norm, and many astronomical observatories started capturing the night sky and started doing photography for science, not just for the pleasure of it, but for capturing science, and started using these photographic plates and taking images and trying to understand a lot of phenomena. Suddenly, photography also started getting used in understanding spectrum from different stars. And that's a whole new realm of photography and astrophotography, and how photography and astronomy came together, and science evolved. The science of astronomy evolved. But why am I showing you this image of Kodaikanal Solar Observatory? Because what was interesting, and what is still interesting, I don't know how many of you all know this, but Kodaikanal Solar Observatory is probably one of the oldest observatories in the world, which has more than 115 years of non-stop observations of the sun. It was initially started by British, and it was in Madras. It started as Madras Observatory, which started for doing survey and things of that sort. And from Madras, it was moved to in early 19th century to Kodaikanal, and this building was built over there. And till from 1900 till today, even if you go today to Kodaikanal, you go around 8ish in the morning, you'll find two people who will be coming there and using the old telescope. They are actually, and using photographic plates, they still today, they take an image of the sun. It's not that the observatory is not equipped with modern equipment. Today, everything has become digital, but they're still continuing this so that they have enough overlapping time and trying to, have significant comparison between the old images and now. And many of these plates are constantly digitized. So you can actually go to Kodaikanal Solar Observatory website and see the sun, how it was maybe at the time when you were born and things like that. So you can actually put your date of birth and download the image of the sun on the day that you were born. So I had an amazing time to actually go there and see the entire institute. And it also hosts one of the oldest libraries in India, astronomical libraries. And if you see some of the books out there, the best part about Kodaikanal Solar Observatory is that you will get the entire evolution of astronomy in that small place. I mean, evolution of astrophotography in that small place, right from taking notes and maintaining a chart of the night sky to actually drawing and sketching the solar observations. And even they do have night sky sketches that were done by the astronomers, to to preserving some of the oldest possible photographic plates. This gentleman here is one of the project assistant out there who's actually digitizing all these old photographic plates. And if you see in his hand, he's actually holding a plate from December 15th, 1904. So it's almost 115 years old. And this is how the sun actually looked 115 years, 120 years back, kind of a thing. So let me and show you a small short video of the entire process. So you'll get a glimpse of how they actually do it. So this is the telescope opening in the morning. This is a very old 6-inch telescope. So they align it to the sun in the morning. So the sun's image is projected on a small white paper. So they kind of center it. And once they have achieved that center of it, they will install a photographic plate. And then use a simple mechanism of clicking. There's a small slit which lets the light inside and exposes the plate. And then they nicely wrap the plate and they take it to the developing lab. And once they have the chemicals ready, they actually use the old photographic methods of developing it. And that is the image of the sun that they captured for today. So this process is still on, and you can actually go to Kodaikanal Observatory and have a look at it and see it. It's amazing just to see. And you can actually go and see the entire archive. It's also digitized, so you can even see that archive online, kind of thing. So what astrophotography started way back with all these daguerreotype instruments and photographic plate. But today things have changed. Today, we no longer use any of those methods. We have developed sensors like the CCD or the CMOS sensors, and the cameras have become amazing, smaller, handier, and you can take them to any places, weatherproofed. And the entire realm of astrophotography and photography has changed for that matter. And if you remember the first image by Henry Draper of Orion Nebula, this is what it looks today. I mean, this is an image from Hubble Space Telescope. If you see what was clicked probably a century ago with the old technology, and today you can use a lot of false color compositing. You can take images from different filters and then get such detailed, beautiful astronomical capturing of several astronomical data and things of that sort. So apart from using it for science, for visually also, it tells you a lot of fantastic things about these beautiful objects up in the sky. Modern day cameras have changed a lot. So many, if you go to any astronomical observatories today, they don't use a DSLR. They use a much more advanced camera called CCDs. And CCD and CMOS are two different technology, or the chip technologies are a bit different. We will not dwell much into it. Probably I'll leave it for the detailed later on. If anybody is interested, let me know. Then probably I can talk about it later. But these are some of the CCD cameras that the astronomical observatories uses, and they're relatively extremely expensive. So you can have a CCD camera as cheap as a lakh or two, and it can go even all the way touching to 1 crore. The kind of the sensitivity and the thing. So many observatories have 50, 60, 80 lakhs, 1 crore kind of CCD cameras. So these are expensive, and they work a lot. I mean, in capturing the data kind of a thing. Coming to the pro consumer or our level of cameras that we can have are these DSLR cameras that today I would not talk about any specific, because I keep getting asked by many people which is the best brand to do astrophotography. I don't think there's any brand as such. Every camera has its own pros and cons, and the best camera is the camera that you have. So yeah, I mean, and everybody nowadays have, so you can ask about the technicalities, which is the best camera. So again, I would say it's the best camera is the camera that you have, but even in them, you'll have something called as a crop sensor and a full frame sensor. I'll be talking about it in detail probably in the next session that I'll be doing. So today I'm just going to tease you all a bit with a lot of astrophotograph and try and motivate you all to get into astrophotography as an interesting hobby, or even I have several friends who have actually started contributing astrophotography for science. So I'll talk about it. DSLRs are not the only form. Today, mobile phones are becoming so interesting and so amazing that today mobile, if you see any of the ads of the phone, they don't sell you the mobile phone. I don't know even why they even still call it as a phone. It's no longer a phone. People don't buy a phone for the talking purpose. They use it, and even many of the companies, they market the phone for their camera or for their high graphics for playing games and things like that. But majority of them market it for the camera. And some of the new phones, there are some phones which have come, I think Poco and Huawei's some P330 or something, or P30 or something like that, which have got incredible night sensors. And you can do, people have done such amazing night sky photography with a phone. I mean, it's very stunning that a small phone with a small sensor can actually do so much amount of things. So even phones are there, which we'll talk probably later or next session. Modern day cameras also have these small sensors, and many observatories also use them, something called as all sky survey cameras, wherein you can put up a fisheye lens on top of it and you'll get an entire 360, I mean 180 dome project capturing of the night sky. You can actually see the Milky Way. And apart from the beautiful imaging that can happen, the thing is, and these are amazing, especially when you're having a meteor shower. You can, and when you have bright meteors especially, they look stunning, seeing them pass through from left to right or from one place to another place. But a lot of science can also be done in form of transient events like variables or even comets or things of that sort, using a simple cameras like all sky survey cameras. So what are the events that you can actually photograph when it comes to astronomy kind of thing? So you have daytime events that you can do, like eclipses and things of that sort. I'll show you across. Then there are deep sky events, deep sky imaging that you can do, like galaxies or clusters or nebulas, and even some comets or asteroids for that matter, eclipsing asteroids and things of that sort, which are extremely far and you need a good tracking telescope for it. Or something that I love doing the most, that is the landscape astrophotography, because this is something that I have been doing a lot, because it gives you a sense of where you are, and with the landscape and with the astronomical background and the night sky background, it actually has a different meaning altogether when you see those images. So let me just quickly show you some of them. Daytime events. So what you can do during the day is, one, you can photograph sunspot activities. Currently, I'm not sure whether we're into minima phase, but when during the maxima time, you have lots and lots of activities and interesting sunspots formation, and you can actually track from the left limb to the right limb. And if you make it into a project of documenting it almost every day, then you can actually do a lot of interesting calculation about the rotation speed of the sun and things of that sort. And but very importantly, do not point your camera or even your eye directly to the sun, because it's extremely harmful. And especially if you're using a telescope to do it, you need to have these filters. Okay, I can't make it explicitly important to tell you all that please use a filter. There are a lot of people also who have used X-rays, overexposed X-rays and things. So even I'm one of them, but then don't recommend it, because even X-ray sheets, overexposed X-ray sheets, they're not fine. They can still have small amount of light, direct UV light entering the telescope, and even can either burn your sensor or even have issues, can give issues to your retina. So there are these special filters. They can be Mylar filters or Bardo filters, or you get special solar filters. H-alpha filters are also very interesting, but a bit expensive. But these are very cheap stuff, Mylar and Bardo filters. So please use them if you want to photograph the sun. And apart from sunspots, a lot of interesting events happen when you have the inner planets like Mercury and the Venus passing by. I don't know if you can notice it over here. You can see these small dots passing by. That was the Mercury transit that happened a couple of years back. And we also had a small sunspot. And it happened in the evening time when the sun was about to set. So I also used a long lens to actually capture a bit of landscape from the place where I stay, from the terrace. And you had the sunspot and the Mercury out there. And since it was evening time and a bit hazy around and things, so the landscape don't look so prominent, but then it gives you a very interesting aspect. If you look at it, like you're on the Earth, you're looking at inner planet Mercury just crossing the sun. So it gives you a lot of significance of where you are in the universe, kind of thing. So that was a small telescope that I had attached, and my wife was also photographing it with another camera. And eclipses are something which are extremely fun and interesting. This is one of the eclipse images that I took from Dhanushkodi. That's in Rameshwaram. And it started from 10 o'clock in the morning till 4 o'clock, and you had a perfect ring of fire, as they say. Unfortunately, after this, we had a solar eclipse event in 2009. 2009, we had a solar eclipse event which washed out, and I was fortunate to go here in 2010 and get this entire sequence right from the second contact and the third contact and the ring of fire, as they say. This was another event that happened just before the COVID. I was in Kodaikanal again. We were not exactly on the line, and hence I did not get the full ring. But it was a different thing to being at the observatory and photographing it with all the people, and very interesting, prominent people coming out there, whom whose books I used to read as a child, or early in my college career, kind of a thing. And they were there. I had an opportunity to meet Professor J. Pasukov, who has seen 94 or 95 eclipses, and he's a 85-year-old man. kind of a thing. So it was very interesting to meet them and things of that sort. But this is one of the images that I captured from Kodaikanal Solar Observatory. So you can capture the entire sequence. So this is all during daytime. So you don't need any fancy equipment for this. You can even use your phone with a filter, or you can have it attached to a telescope, or else a DSLR with a regular kit level zoom with a filter in front of it. So these are each easily clickable kind of events. You don't need expensive lenses or expensive technology to capture these events. Yeah, this was a partial eclipse that happened in Goa. Again, during the lockdown time, so we could not travel to any of the place where the totality was supposed to happen. But we managed to actually see this partial phases from my terrace out here. But what interestingly we did was, there were a lot of people who were saying that we don't have a filter, but we want to see the eclipse. How do we watch it? So we just gave them a simple idea of using this strainer and just projecting it. And I just tweeted it on, I just put it up on Instagram and asked people to just try it out and send their photographs. So I was very happy to see more than some 80 to 90 people trying it out and clicking their image and sending it across. And this, what you see, the hole from that strainer actually acts as a pinhole, just like the Camera Obscura that we started the talk with. And it started showing the phases of the eclipse in that kind of thing. So many people, they started sending it across. There are a couple of very interesting phenomena that you can also capture of the sun. This is one image that I captured from Mount Abu Solar Observatory. This is called a green flash. There is also something called a blue flash and a purple flash, but they are extremely rare to actually photograph them unless you have some amazing conditions and on extremely high mountain top and things of that sort. But green flashes are extremely common. If you get a good line of sight and good atmospheric conditions, keep watching the sun just before it sets down. You'll just see the tip of the sun and it will give you an amazing green flash. So here you can see it, how prominently that flash is visible. And sometimes you get some very interesting phenomena of this trailing of contrails from high altitude jets, which might be flying at 35, 40,000 or 50,000, 40,000 feet. And they give you a trail of line kind of thing. So that was our daytime event. But if you want to do deep sky, then you need specific equipments that can track your object. You need a telescope, or else you need a long zoom lens and lots and lots of time to actually capture it and process kind of a thing. So this is my attempt to capturing Orion Nebula. This was the first and the last attempt that I did, because I'm not such a big fan of deep sky astrophotography, because it's a different level of craziness that you need to be a deep sky photographer. And it takes a lot of time. You need a lot of dedication to do it. You need good skies and good equipment with proper tracking, proper thing. And you need to, get in huge amount of data. And then you process it, stack it, process it to get some good images. So these are not great images of mine. But yeah, I just thought I'll just put it up just to show you all. Of course, comet deep sky imaging is very interesting, especially when they get formed and when you can actually track them. If you have good amount of tracking days available to track the comet, you can see very interesting features right from when it turns from almost whitish to the greenish glow because of the cyanide, and when the tail dissociates, or when the tail, the iron tail and the dust tail gets formed. Kind of thing. This was way back in 2013, again taken from Mount Abu. This is the comet Lovejoy, R1 Lovejoy, which was there. And at the same time, since we had the time and the telescope out there, we actually put our camera on top of it, and we actually got some deep sky images of some of the galaxies that are there, the Messier objects that are available. So for a deep sky astrophotography, you need good equipment, which can be a bit expensive to start off with. Even the basic, if you want good quality of imaging, you need good equipment, which are sturdy, good tripod, good tracking, and good imaging or good glass to your telescope, and a good amount of processing power. And at the same time, the most important of all is good amount of patience, because you need to sit a long time just to get the data. So, and it's also bulky. You can't just put it up in your bag and take it. You need to have all kinds of transportation equipment. You'll have to have a car to move these telescopes, and these are electronic telescopes can have a lot of issues and things of that sort. But it's worth a while if you have the time and the money to invest on it. But this is something that I love to do. That is the landscape astrophotography. Yeah, for almost 5-6 years, I have been doing this, and this is again at Mount Abu. Just prepping up or dressing the scene, as they say, just use a green laser and just flash it up and get a selfie clicked by putting a camera on a timer, and you have the beautiful Orion along with a landscape, some important landscape that people can kind of associate or recognize with. So this is the Mount Abu Observatory, MIRO, and this is the observatory at Kavallur in Tamil Nadu. This is the Venu Bapu Observatory, which hosts the 2.3-meter telescope. And what you see here is the cross, the Southern Cross or the Crux constellation. And this is the southern sky. In fact, you're looking towards the south, kind of a thing. And this is another observatory, another telescope called J.C. Bhattacharya telescope at the Venu Bapu Observatory itself. And you have the Ursa Major constellation. So these are simple stuff. You just need a DSLR camera with a wide lens and a sturdy tripod, and you are good to go. You can just travel to any place. You can hop on to any place, fix the camera and shoot your night sky. Sometimes you can be a bit more creative. You find trees which don't have leaves, kind of thing. So you end up putting stars in the backdrop, just showing as if the trees are lit with stars. You can go to any level of creativity out there. And sometimes if you see the foreground, there might be very interesting subjects like an anthill out here and the same tree. And you can use a simple torch just to dress the scene, giving a long exposure, and at the same time getting the stars in the backdrop. From that particular observatories in the south, we did move to Pune, close to Pune, a place called Narayangaon. That's the GMRT telescope. I think we're running off the time, but okay, I'll quickly go through them. The GMRT telescope, if you see out here, and you have the beautiful Ursa Major out there. And we also asked the people out there to dress up the scene by just putting up some light and capturing the planet Jupiter in the backdrop. And this is how it looks during the daytime. Let me just quickly, show you the photographs because we don't have so much amount of time. Hey, how long, Vaibhav, if you're around, how long can we extend this?
Yeah, we are free to go ahead.
Okay.
Very interesting talk, so please do.
Okay.
Yeah, I agree.
Okay. Yeah, I have that problem, once I start talking, it's very difficult for me to stop and I just lose time. But then I hope you're enjoying some of the photographs. So I'll just quickly go ahead. So yeah, we have the GMRT. This is how it looks during the daytime. And it's a beautiful place. So if you have to, kind of photograph, be there, and if you're around that town, then please go there and try and get some night sky shots done from there with a landscape in the foreground. So from the south, we again moved right up to the mid regions to the Mount Abu Observatory. I'm just also showing you some of the photographs that we actually clicked as a part of the Astro Project documentation work. This is how it looks in a full moonlit light at Mount Abu Observatory. And this was a question, but since we are not having the interaction kind of a thing, I wish it was a physical workshop. I would have asked you all whether is this taken during sunrise or sunset. So when I generally do this, I do end up getting answers that it is during the sunset, because you can see the orange horizon out here. But then if it is sunset, you don't end up seeing so much of stars. Then suddenly I get moved on that it is sunrise. Even if it is sunrise, you won't see so much of stars because there's already a glow which happens much before the sun, actually the pre-dawn conditions. So this is actually not sun. This is actually the moon. It was the moon which was setting, and during the month of December, what generally happens is we get these westerly winds from the northwest, and you have a lot of dust that comes from the desert area. and that dust actually settles as a layer. And whenever moon passes down, it actually scatters into these orangish glow. And it's a beautiful thing to actually see the orange glow and all these Orion constellation and the Pleiades and all the other thing, kind of a thing. So if you notice that dust that I was talking about, this is I guess it is there's a small town below Mount Abu. I'm forgetting the name of it. So the amount of light pollution, if you notice, and you can see the dust layer. Now, this photograph is a very interesting photograph because you can see several interesting astronomy features that, or a lot of features. I won't just call it astronomical, but a lot of physical features that's been happening out there. You can see the light pollution. You can see the dust, which kind of creates an inversion layer, which doesn't let the light kind of pass up about the particular layer. Since we were above that particular height, we could see that particular layer out there. And if you notice, there's a meteor which passes by. This was taken during Geminids meteor shower. And just on the left of it or right of yours, you'll be able to see this a trail of a bright object and a dust. This was the comet Lovejoy, the green nucleus or the center, and the dust around it, which actually passes all the way across. No, sorry. Yeah, all the way across. But this was way early in the morning, around 5:30 or something, 5ish or something. So we had the glow from the early morning sunrise that was about to happen. So we could not give a longer exposure because it was kind of, and with so much amount of light pollution, it was very difficult to actually get this particular photo. But we were very happy that Geminids meteor shower, we were able to capture a meteor and a comet and the inversion layer and the light pollution, and with the landscape in front and the stars in the background. It gives you an interesting sense of feel to the entire thing. Also, you end up seeing some interesting glow. It actually, when I saw it for the first time, it took me some time to understand what is happening out there. I thought it was a typical light pollution kind of phenomena, but then we realized it is not light pollution. It is something called as a zodiacal light. Now, zodiacal light is nothing but in the interplanetary disk between, say, the Earth and the Sun, there's a lot of dust particles in the the elliptical plane. So that actually scatters light, and it gives you a column of very interesting column of a ray of light that happens out there. So this is just towards the east that you're seeing just before the sunrise. So even the sun will rise like this in that track. So this happens. You can see them just before sunrise or just after sunset. From Mount Abu, we headed to Himalaya. And I don't know even what to call that particular place. It's really the heaven on earth. And probably when you see Dorje Anchuk's photographs down the line when he'll be doing the webinar, the skies are there. He literally lives in heaven. This is a small exposure of hardly, I guess, 20 seconds at the highest altitude, one of the highest altitude telescope or observatories in the world, the Henley telescope, or the Indian Astronomical Observatory at Henley. And the skies are amazing. And if you might wonder, if you see the first image that I showed you of, where did I show you of the Venu Bapu Observatory, there were hardly any stars that you could see, and there was a lot of glow around. That's all because of light pollution. Now, this place is at 15,000 feet. It is almost like 60% of the, about 60% of the Earth's atmosphere. And moreover, it's in a place where there is hardly any light available out there just to scatter and spoil the sky. So it's a mecca for astronomical observations. And it's very difficult to actually be there and photograph because outside temperatures are somewhere -10, -15 when I had taken this. And it's high altitude, 60%, so less oxygen, almost like 40-50% of oxygen out there. And even the smallest task of taking your telescope or taking your tripod and walking up to a hill to get this particular vantage point is actually very difficult at times unless you're properly acclimatized or unless you're a local out there. So for Dorje being a local out there, for him it is fantastic. He can manage, he can run around. But for a person like me who comes from zero MSL in Goa, it's difficult. But then somehow after getting good acclimatized, we did this. This is the center of, this is looking towards Sagittarius constellation. You're actually looking towards the center of Milky Way. And hence you'll see this big glow of patch out there, because there's huge concentration of stars, and it's considered that there's a black hole out there with all the stars around it creating this glow. And you can even see the dark hydrogen nebulae with early formation of stars and things of that sort happening out there. What other interesting phenomena that I ended up seeing in Ladakh, in Henley, is that I took these photographs, a series of photographs, and they started giving me this pink glow. I initially thought, and I had not seen this glow before, kind of thing. I initially thought, and you can't see this glow naked eye, because they're very faint. Your camera can capture them because you're giving a longer exposure, but when you see it with unaided eye, you don't see this particular glow so well. I started getting scared, thinking that maybe my sensor is not reacting properly because of the ambient temperature is -20 or -15, -20, and the altitude and things of that sort. So I literally shut the camera for some time and then started it again. Again, when I clicked it, I had a glow, but this time the glow was, if you see between the previous photo and now, the glow actually moves, kind of a thing. So this cannot be the auroras because we are not in that region. This is just at 20 degrees north. For auroras, you have to go above 70 degrees north, kind of a thing. This is something called as an air glow phenomena. So what is air glow phenomena? You can just actually Google it out. I don't want to discuss the physics side of it, but there's such interesting glow and interesting activity in the night sky that being in city, being surrounded by light pollution, we don't end up realizing these kind of a thing. While we were there in the observatory, we also, there are a lot of interesting stuff. Sometimes it's not always about capturing landscape with, something. You can even just have your camera set up just outside a window. It will tell you that what interesting it is to actually see the night sky while you're there at the observatory, and it gives you there's a bit more emotional connect that happens with, and it also, I feel astronomy is one subject that tells you how insignificant we are, considering the entire universe and things of that sort. And I feel it's very important that we delve a lot more into astronomy with all the kind of problems happening today in the country or in the world. Probably it will put a lot of people in place when we try and portray them the actual insignificance that we are in the universe, kind of concept. Apart from that, you can also do very interesting capturing of different objects. Like this was one of the occultation phenomena of this particular star in Taurus constellation called Aldebaran with the moon. Unfortunately, I was not in the line of sight where the star would hide behind the moon and come out from the other side, but nevertheless we wanted to capture it, so we captured it and we timed it. And you can actually, if this event has taken place from different places and you do the math, you can actually tell a lot of things about the size of the moon, the diameter of the moon, and you can calculate a couple of things with the parallax side of it. So timing becomes very important. You need to time your events. A few months back, during the COVID, post the lockdown scenario, we had this great conjunction of Jupiter and Saturn. And I took this image. This is very close to my place. It's just a water tank. And what you see here is the Jupiter and Saturn out there, kind of thing. And somehow, and I just put it up on there and hashtagged it, kind of a thing. And next thing I know that it was shared on NASA TV during one of the talks, kind of thing. So this was the scene. This is the place. This is just at the university water tank, where I live very close to it, kind of thing. So you can dress up your scene, but with these landscape shots, and also capture the astronomy event in the backdrop. You can even make it more interesting. I went to the beach out there, and you can have the ocean and all these sand wave ripple created sand patterns along with the moon and the astronomical objects of Jupiter and Saturn. You can make it interesting. There was a tree which was fallen out there just to dress up the scene rather than just focusing just only on the astronomical object. If you dress the scene, I mean, create it more with a lot of elements where you connect the earth and the sky together, and you can become a bit more artisty in this sense and capture the sky and things of that sort. Early evenings are also very interesting because you have the sun that has set and you have these afterglow and the clouds at that particular altitude still reflecting the sunlight with the red light and the purple hue all across, and having the astronomical objects out there. It also kind of creates interesting. Very interesting thing to capture are star trails. This will take a lot of time to actually do it, but if you do it, it's fun to do it. So how to do it and everything we'll talk in the next session, where I'll show you a couple of things and methods of doing it and things of that sort. So this is another star trail that we actually captured from Mount Abu. If you see, there are a lot of gaps out here, and unfortunately, while I had put the camera on and it was extremely cold, so I left the camera on for capturing it for almost 3 hours. And during that 3 hours time, the security guard of the observatory, who did not know that there's a camera on, he moved all across this place by flashing the torchlight kind of thing. So there were a lot of frames wherein the torchlight is focused straight away into the camera. So I had to delete them. So, but if you don't miss those frames, then you'll get beautiful structures, the lines out there. And how to do it, where to do it, and everything, probably I'll take it up into the next webinar when we do it. If you notice, if you point your camera towards the north, because the North Star towards the north, you have the North Star, which is a circumpolar star, and rest all the other stars tend to revolve around it. It's actually not the star, but it's the Earth's rotation that makes you feel as if the star is revolving around it. But this is when you put your camera towards the north or the south direction. But if you shift your camera towards the east-west direction, you'll end up seeing a star trail like this. You won't see those concentric rings, but you'll be able to see the star in form of an arch kind of thing. You can also do some nightscape photography, especially I just captured this just before, start of this time's monsoon season. I called it as if the Thor has landed on Earth, kind of a thing. So this is not a single image again. This is actually 3 images stacked on top of each other to actually give you the entire, interesting sequence of the lightning that happens. So what are the tools of trade? So I just showed you a couple of images, but what are the tools of trade to do landscape astrophotography? I won't talk about deep space astrophotography because I don't do much of it, but I do a lot of landscape astrophotography, so I'll stick to that side of it. So you need a DSLR. Any DSLR will do, whether it's Canon, Nikon, Sony, Panasonic, or Fuji, or anything, it doesn't matter. But as long as you have an option to manually set your shutter speed, your exposure, and things of that sort. You need a sturdy tripod, and because you have to give longer exposure, and you can't shake or move the camera, so you need a sturdy tripod. You need wide angle lenses to capture as wide as possible. You can use sometimes telephoto lenses, but then there are a couple of rules that get attached to it, which probably, I think, because of shortage of time, I'll talk in the next series kind of thing. I'll skip directly to the last slide now. And you need a remote, so that you have to trigger it without touching the camera, because every time you touch the camera, or else you can put it on a timer, but when you touch the camera, that entire physical motion ends up shaking the camera at times. And of course, you need a flashlight for 2 reasons. One is to check, because you're working in nighttime, and sometimes you can use that flashlight to dress the scene. Do something called a light painting. So all of this will probably talk in the next session. But couple of things that that I would probably, I'll also end it up with that in the next session itself. But probably one thing that I would definitely want to say is astrophotography is something very interesting, and never be under the guard that you can't capture it. So because if you can see it, you can photograph it. That's the thumb rule. How to do it is the technicalities of it. Probably we'll do it in the next session. But if you can see a phenomena happening, you can photograph it. Like for that matter, this particular photograph I took during one of the expeditions to Antarctica. I did almost 3 expeditions out there. 2 expeditions, it was unfortunate I could not see a single auroral activity because they were summer expedition. But luckily in the 3rd expedition, due to some issue, the ship got delayed and our travel time got delayed. And I actually could spend 15 to 20 days in the early winter time, and the dark skies were there, so I could easily see a couple of auroral activities out there. So if you can see it, you can photograph it. I've seen many of them who want to get into landscape or astrophotography for matter, but then they have issues with cold, they have issues with mosquitoes biting them, they have issues with all kinds of things and things of that sort. So if you want to photograph something, you need to get out and shoot. You can't give excuses of not doing things of that sort. Patience is a key for a good image, because you might have, there'll be thousands of images that you might have to try to get sometimes a good a worthwhile image that you can think of publishing or capturing or having a very good relevance. There are times when you want to capture an event just to get that one photograph. Or I remember this was during the Venus transit, and there was this phenomena called as a black drop phenomena that it's a optical illusion. Basically, when Venus touches the limb of the sun, because the bright sun in the backdrop, it shows as if Venus has got a tail. And this phenomena lasts hardly for 2 seconds or 3 seconds. But in order to capture that particular thing way back in 2004, and we never had, at that time, we never had the money, we never even had the equipment with us. So what we did is we actually modified a web camera and stuffed it into a telescope and try and capture it. It was just for that 3 seconds. We actually spent the entire day, looking up, getting ourselves baked in the sun so that we get that particular. So patience is key just to get that one image. And you have to go the extra mile. At times we go to a place and we stand there and put up the telescope and say, oh, the scene looks good, and you photograph it. But then suddenly, if you just hike up maybe some 100, 200 meters away or higher or something like that, you might suddenly end up seeing a different landscape altogether. So you need to sometimes go that extra mile to actually go and photograph it. Now, there are a couple of other rules that gets associated with it. Even when you do all of that, you need to check your surroundings and things of that sort. So I'll be talking about that probably in the next session. Kind of thing. I don't want to complete everything here because this is just an introductory first webinar, and I'm sure there are a couple of other speakers who will be talking in depth, in detail. So about astrophotography and a couple of other things. So yeah, at the end, I would just say thank you, and I hope y'all are excited watching the entire thing. And 1 second, yeah, and I hope it was fruitful and I could motivate you all to get into the art of astrophotography to start off with. Yes, if there's any questions, we can take it up, or else, yeah.
Thank you so much, Rakesh. This was amazing. I enjoyed every minute of it. So yeah, so like you already mentioned, so this was a very motivating talk for all those who are getting into astrophotography. And I'm sure also in the following sessions, other speakers and you will also be talking about some of the details.
Yeah.
I could personally connect with a lot of it because I have spent a lot of times in observatories, even Venubakku Observatory. That's where I did my first bachelor project. Okay. And I was in some very old observatories as well, like in Heidelberg and Paris Observatory, where they still use those very old equipment.
Right.
And they are also digitizing a lot of the earlier material. So this is something I could connect with. I have also developed photographic plates for my optic experiments.
Wow. Right.
So yeah, and I'm looking forward to learning more during these sessions so I can try them out myself. I have a question, but I think maybe you will talk about it in the next session.
Sure.
So like I personally, I love to do Himalayan trek. So I like if it is a multi-day trek, then I try to minimize my equipment. So I would really like to travel light. So maybe you will talk about some tripods, some innovations that we can do in order to have the setting. And the other thing I'm a lot worried about is like the cold and because of which the batteries always run out.
Right.
So maybe you will talk about this.
I'll anyways, because you have asked this question, I'll anyways take the second question first with the battery issue. I do agree. There was a time when many of these camera manufacturing companies, had these batteries that could, function only from like, 5 degrees to like 25 or 30 or 40 degrees kind of thing. Anything below 5 degrees or sub-zero degrees, they start draining out very fast. I did face this issue when we went for the Antarctic trip also, because it was all -20, -30 and things of that sort. But today's technology, today's new equipments, today's new battery kind of a thing, and the weatherproofed cameras that have come, I haven't faced any issue as such, even working in extreme conditions with blizzards and things of that sort. It's not just for astrophotography, even for regular photography. I did face some issues with the lens focusing because of ambient temperature so cold that sometimes these some of not so well, or the third party lenses, they use sometimes cheap stuff, so they tend to contract a bit because of the negative temperature. So the servo motors inside don't focus pretty well. And but today I think there's no problem. Today, in fact, today's cameras, you can even use it in rain without getting any issues, or mild rain, not heavy rains. But I mean, that's the thing. And for sure, I'll be talking a bit more in detail in the next session, where we schedule about the technology, the equipment. I'll be even showing some of my equipment, what I end up using, the lenses and things of the sort, and what is shutter, what is aperture, what is ISO, and even phone, and what are some of the apps that we can use to enhance and understand about the events in astronomy and things of that sort. So I just thought, because this is our first webinar, I just wanted to show and get people motivated about what are some of the events that we can capture. Because I've always noticed this, whenever we do, people think that only if we have a DSLR, only if we have the best DSLR, only if we have the best lens and the best tripod, we can do astrophotography. In fact, that's not the fact. Many of my earlier images that you saw were done with very cheap cameras and cheap lenses and cheap tripods that were there. Kind of thing. I never had the money always, it's just that now we can afford something to do it only once you're passionate about it.
Awesome. Are any of the participants, does anyone have any question? I don't see any hands up.
Yeah.
Okay, Prasun.
You can unmute. Yeah.
Yeah. Am I audible?
Yeah.
Yes.
Yeah, Prasun.
Yeah. Thanks, Rakesh. It was amazing. Yeah.
Thank you.
I was asking, like, I regret something. Like, I was in village, and it was a new moon night, and suddenly there had a blackout. The stars were amazing, but I couldn't capture them. I had nothing. I had just my phone at my hand, and just what to do with a phone with that hand.
Yeah. So phone, although the technology has changed now, there are few phones which have their inbuilt, nothing great about that they have changed the sensors or something like that. Of course, they have added a couple of features to the sensor that helps you, get a good amount of night sky light, but they have just enhanced the processing technique. They have some kind of an artificial intelligence things added to it that helps the camera understand the scenario and kind of enhance that particular thing. So phones do have an option. Some of the phones now, not every phone has, but then today, if you buy the latest phone, they have something called as manual mode in the phones also, or the pro mode it is called in some of the phones. So you can actually go to the manual settings and you can change your shutter, your aperture, and a couple of things, the ISO and things of that sort, and you can use it to capture. Having said that, the images that you might take on the phone will always look good only on the phone, because moment you shift it from phone to a desktop, which has higher resolution and a bigger screen, you'll find it a bit pixelated kind of a thing. So you might feel a bit disappointed, but yeah, I mean, it's just about capturing that moment at times. And having said that, there are times, it has happened to me, just to share one experience, although not astrophotography experience, but when I was in Antarctica documenting these penguin rookery, I had been to one of the penguin rookery and we had these emperor penguins. And there was this time wherein the father penguin or the male penguin actually, removes a kind of a liquid and stuffs it into the mouth of the baby penguin, the chick. And that because the mother penguin has traveled all the way up to the sea to fill her stomach, kind of a thing. That's a different thing altogether. But when I've captured that entire thing, but when I came back and realized, I spent my entire time of capturing it just behind that viewfinder, with one eye shut and just behind the viewfinder. What I'm trying to tell you here is that sometimes you just have to enjoy the moment. It's okay to not capture things. It's okay not to. There are a couple of things, even that green flash, it was very fluke that I ended up getting it. But after that image that I've captured, we stayed there for almost 10 days, and almost literally every day we ended up watching the green flash. And I stopped photographing it because I wanted to capture that memory and see that particular event. So that's what I would say. Sometimes we get too bogged down, oh shit, there is a meteor shower happening, we have to capture it. And in that process of doing it, we end up forgetting, experiencing, enjoying the event. So I would just say, Prasun, if you did not have any camera at that point of time, it's okay. You just enjoy that phenomena. But if you have enjoyed the phenomena enough, then probably you can remove your phone on your DSLR camera and then capture it. And probably I'll be talking a bit more about mobile photography and how to do it in the next session.
That's awesome. So Shaptarshi has a question. Shaptarshi, yes. Can you unmute?
Yeah, I recently bought a 130 reflector. It's a manual, not computerized. So how can I go into deep sky imaging?
So for anything to do with deep sky, you need a tracking. Right, because the objects that come, the light which comes from these deep sky objects, whether it's the galaxy or whether it's nebulae or whatever, they're very faint. So in order to capture that, you need to have a tracking. You need to give a longer exposure. Now, if you put your DSLR to a non-tracking telescope, after some time, what happens because of the Earth's rotation, that object will move from the edge of the viewfinder to the other side. But still, when you've given a long exposure, you'll find the trailing or the entire thing is going to go blur. So what you will have to do is probably you get these motors which are available, they're called RA or DEC motors. So you can just do a bit of research on that, the RA and DEC motors. If it's not a go-to kind of telescope, and if it's a manual telescope, you can still attach these servo motors which come and which will actually track depending on your latitude. You'll have to do a bit of polar alignment to your telescope if it is an equatorial mount, and then slowly it will keep tracking in one direction. So you can still manage, and these are cheap. The motors are pretty cheap. You'll get them for like 5,000 or 7,000 rupees or something like that. So you can just attach it, and you can attach your DSLR. You'll need to balance your telescope. That's very important because an unbalanced telescope will not track the object properly. So there are a couple of things. You need to have a good tracking. You need to have a good place where there's no vibration. You'll have to polar align your telescope, and you'll have to buy this RA DEC motor that will help you track in one axis and give a long exposure. And instead of capturing one long exposure, what you'll have to do is capture multiple exposures, like 20 or 30 seconds. Instead of like, say, if you want a good image and you have to give at least a 5 minutes exposure, instead of giving a full 5 minutes exposure, and it can have issues, what you normally do is you do 20 seconds or 30 seconds multiple exposure. And there are methods, there are softwares which are readily available that you can use these multiple images, put on top of each other and stack them. So when you stack like 10 images or whatever it is of 30 seconds each, that will be like almost like a 3-minute long exposure, or 12 minutes long exposure, kind of a thing. So I hope that answered you, Rashid.
Okay, so Piyush has a question.
Yes, Piyush.
Piyush, please unmute.
Yeah, hello, sir. That was a great talk.
Thank you, Piyush.
Am I audible?
Yeah. Go ahead.
Yeah. So I have done some basic stuff on astrophotography from my cell phone. And
Okay.
I wanted to ask that what are the use of the support frames, like the bias frames and the flat frames? Some astrophotographers use that, but I don't understand what is the use.
Sure. So probably this is what I'll be talking in detail in the next session. But just because you have asked, let me just explain to you a couple of things. What normally used to happen is, before, when we had these, film technology, I mean, using the film roll kind of a thing. So anything, when you expose anything for a long time, you get the films used to produce something called as grains. But in digital format, you have something called as noise. Now, noise can be of two forms. One is because of long exposures, you have unwanted light which comes, kind of thing, and also the sensor gets heated up after some time, so it kind of produces an electrical noise. And at the same time, there are noise that can also get produced because of ambient temperatures, the sky conditions, and things of that sort. So what we end up doing is, when we take multiple images of the night sky, we also end up taking something called as dark frames. Dark frames are nothing but we just shut the camera in front, totally blacken it out, not letting any light, and again take the same exposure. Like if you have taken a 30 minutes light exposure, 30 seconds light exposure, we also take a 30 seconds dark exposure. Now, dark exposure for 30 seconds, it will actually give you the same condition of the sensor heating up and will give you those artifacts on a dark frame. Then you have something called as bias. Now, bias is nothing but it's electrical noise. Whenever you have any electricity passing through anything, there's some amount of electrical noise which end up getting produced in these sensors. So you end up taking bias by clicking the highest shutter of that particular camera. There's also another thing that astronomers end up doing, is something called a flat fielding. Now, what is a flat fielding? Is basically when you have any glass will end up having something called a vignetting effect, meaning the edges of the image will have a bit of black kind of darkening that happens. So what we end up doing is, before we start any astrophotography session, we end up looking at the evening sky, a proper well-lit sky, not extremely bright, but a diffused light, and we take multiple images of it. And all these images, with the light, the bias, the dark frame, and the flat, you end up subtracting it from the main light. So all your noise and everything is cancelled out. So you increase the signal and you reduce the noise by doing that. How exactly the process happens and things of that sort, I'm sure you're going to hear it in the talks by some other people also, but I'll also be talking about it in detail in the next session. So today's session was just to introduce you all to, get you all motivated to get into astrophotography and things of that sort. But it's a tedious process. Okay, astrophotography, you will, frankly speaking, you will not learn it only through this webinars. It's a trial and error method. The more you photograph, the more you read, more you research, and more you experiment, you will start learning it by yourself. Yeah, Piyush.
Piyush, yeah.
Yeah, there's another question that in the Newtonian refractor type telescopes, we have this called chromatic aberration.
Yeah.
So how is there any solution for that?
See, if you have these the cheaper telescopes kind of a thing, then they end up adding all these problems like chromatic aberrations in Newtonian is not so significant as it is significant in a refractor type, which uses a lens, because a lens acts as a prism. And you start seeing different lights, different bending of light that happens because of these prismatic effect. And you see a lot in chromatic aberration in a refractor, refractor kind of telescope, the lens kind of thing. In a reflector, more than the chromatic, you might end up seeing something called as a coma or astigmatism kind of issue, where all the rays don't actually come to the focus. So only solution to it is that you have more amount of data. You have to have your collimation of your mirror perfect. You need to check your mirror, check your there are no dents or there's no anything of that sort to reduce it. It's a physical effect. It's very difficult to just reduce it through just a camera. If you're just using your camera to do it, there are a lot of chromatic issues that come. So many of the manufacturers today, if you import your photographs say, into a Lightroom or a Photoshop for processing, they also have a lot of profiles which you can just download from their website, and they've already done manual corrections, which will, if you import it onto your photograph, they will already correct it for your particular lens issue kind of thing. So maybe you can use that. Yeah.
Next question is from Selenophil.
Yeah.
Can you please unmute?
Hello, am I audible?
Yes.
Yeah, actually, I would firstly like to thank you all for arranging this session. It was really nice to hear it and watch it. Coming to my question, it is related to mobile astrophotography. I'm just starting out to take photographs from my mobile phone and in cities and sometimes outside of it. But what my phone lacks is pro mode or the manual mode that you were talking about earlier. So
right.
Are there any applications that I could download and try to take photographs from them so I could adjust the exposure and the shutter speed and everything?
Yeah, so there are a lot of apps which actually kind of overrides your operating system of your phone, and but these apps are generally used for filmmaking. I mean, you can use generally mobile filmmakers have now started using these apps. So that they have a lot of options and doing white balancing, shutter speed, aperture, and even capturing sometimes in a raw format of your camera. So, but that's a good question that you have asked. Probably I'll also delve more into it, and probably in the next session I'll try to answer this in much more detail. But I'm sure if your phone supports those apps, you can just connect with me probably on Instagram or Facebook if you have noted it down, or you can send a mail or something like that, kind of thing. Then probably I can send you those apps. You can just see if they support that API gets supported on your phone. And if it gets supported, then you'll have full manual control of your camera, of your mobile phone. And then you can use the pro mode in that app and then try and photograph it. But there are a lot of limitations when it comes to mobile astrophotography. Don't expect that you will get some beautiful night sky images that you might end up seeing in many of the DSLR kind of thing, because the sensor size is something which is very important. So I'll talk about it in the next session. What is a sensor size? What is pixel size? And how important it plays, whether it's crop sensor, whether it's full frame sensor, and things of that sort. So yeah, you can connect with me on this. Probably I'll also just find out. And if you have I'll just I'll just type my email ID in the chat box here.
We can also share it on our social media.
Sure. Or a faster method is Instagram or Facebook, because I'm constantly on that. Emails will take some time to answer back. I hope I could answer that. Yeah.
Let's take one last question from Harit.
Yeah, hi. Am I audible?
Yes, Harit.
All right. Firstly, I would like to extend my gratitude to you, sir. It was a highly informative and enlightening session.
Thank you.
I had a lot of doubts regarding the technical specifications of cameras and lenses, but then I'll save them for the next session.
Sure.
My doubt right now is that I live in the heart of Mumbai, and I have started astrophotography using my phone. But the thing is, considering the light pollution over here, it's quite tough to capture the night sky. So is there any workaround toward it, or do I just need to move out?
So
please get out of Mumbai and head to the hills.
That's the simplest and the fastest solution that's there. You have such amazing Sahyadri mountains around, and there are a couple of dark sky patches if you're okay to take a 2 hours drive kind of a thing, whether it's towards Murshi or even Lonavala side. A couple of places are there, but nothing as great of a night sky. It is much better. It is 1,000 times better than what you're living in heart of the city kind of thing. Of course, there are there are these products which are there. There are something called as sodium filters that reduce the sodium vapor glow that the city light gives, and light pollution filters or something like that. But I haven't tried them out, and I'm not sure whether they work good enough in reducing it. So the only workaround for you would be is to capture brighter celestial events, like whether it's sunspots or probably moon related stuff, or some planetary stuff also you can still manage to capture. But if you're thinking of capturing very detailed Milky Way or something like that, you need good skies. So, and it's, by the way, it's just not only about the phone. Even if I have the best of the tools and best of the DSLR and best of the telescope with a go-to mount, and if I'm living in Mumbai, I can still, I won't still be able to capture the night sky or the deep sky object. To capture any of it, you have to go away from the city. If you remember my photographs from the Venu Bapu side, now because of so much amount of light pollution which has happened in downhills, you can still see the glow. But if you see the photographs from Henley, the place is dark sky, and soon there's a lot of thing which is happening to declare Henley as a dark sky reserve kind of a thing. The first dark sky reserve in India. It's in process, the entire thing. So probably I would suggest you pack your bags, head to Ladakh, and I'm sure if you see the skies out there, you would not want to come back to Mumbai. I mean, that's all I can tell you for now, but I hope probably just come down to Goa, even Sahyadri.
Or come to Pune.
Yeah, come to
we
Pune.
are ready to host you. So I think, Harit, if you have a quick question, because I think we have to wrap it up now. Or maybe hold on your questions until the next session. Yeah. Sorry?
I'll just interrupt here. Just before wrapping up, if we can take a group photograph, if everyone can. Oh. Yeah, once
okay, sure.
They're ready for it. If everyone can switch on their video, that will be very helpful, and we can just take a quick group picture. Although we are not together because of the COVID, we are all here, so let's make the most of this opportunity and turn on our cameras. We'll just wait a few seconds to let everyone get a good frame. Yeah, we see most of them turning their cameras on. Okay, so yeah, we'll go with this. So yeah, over to you, Nebula. Thanks.
The word to photograph is the word that I learned from the Himalayas. Okay, the word is Jule. Jule has a different connotation altogether. It's for hi, hello, everything. So every time we do any group photos, we shout Jule. Yeah.
Okay, so thank you so much. So like I said, please hold on to your questions until the next session. So this was just the introductory, motivational first webinar. So thank you very much to Rakesh to take out time. I know you're busy with film evaluations at IISF, and thank you very much for taking time out for this session. I hope everybody enjoyed it as much as I did. And so we are hoping to learn much more in the upcoming sessions. You will also have a few more sessions with us. You also gave a lot of nice tips. So I think the astrophotographers here who are starting out, they will learn through these sessions and be able to participate in the contest. You have already given a lot of tips on composition and artistry. So I'm sure a lot of the participants will be able to benefit from this. So yeah, I think today we can end the session here and we'll continue in the next webinar. Thank you very much, everybody, for joining us. Okay, bye-bye.